Considering the next example, um, we are asked to evaluate this line integral. Now, as you can see, that means the line integral is along which path? It moves in a counterclockwise. So this is included. Now, the only thing you have to do is that this thing forms a cycle. Now, it is not stated whether it forms a cycle or not. But looking at this, the general equation of a cycle, giving x squared plus y squared equals to 4. It's like saying you have a general equation of a cycle which is x minus 0 squared plus y minus 0 squared is equals to 2 squared. And you know the general equation of a cycle is x minus a plus y minus b squared is equals to the radius squared. Do you agree with that? And then after this, we can easily say that, okay, this a and b are the centers. So that means a is at center 0, comma 0. And it has a radius of what? This has a radius of 2. So the radius is 2. So how can you easily draft this out? So this is clearly seen in this format. If you have the y-axis and the x-axis, since the center is at the origin and it's a cycle. So there is a cycle with radius of 2 units, and that is from here. Let's say you have 1, and let's say you have 2 in this case. So this is 2. Okay. So it forms a cycle. To complete this, that means you should also have another point here. Let's say this is also what? 2. And this is also what? Minus 2. And this is what? Minus 2. So by the time you form a cycle in a counterclockwise, you move backward anyhow you move it. Okay. So let's say we have a cycle in this form. So let's say this is a cycle now. This is the center. We have this unit here. We have a negative unit here, and we have 2, we have minus 2. So from here we can decide to give the coordinate. The coordinate here is x is 2, y is 0. And as for this one, x is 0, y is 2, right? And as for this point that we have here, x is 0 and y is minus 2. And as for this, the coordinate you have here is x is 0 and x is minus 2 and y is 0. Take note of that. So then, looking at this, we have to split. We are moving it anti-clockwise, counterclockwise, right? Like this. So this is direction because of this sign, this line integral sign that we have over there. So this is how it moves. So for the positive direction, I have this. For the negative direction, I have this part. So I can say this. Let's call this um part A. Let's start from here to what? Part B. Then from part B back to part A. So now this is going to be here in this case, this for the positive part. So let's find the equation of this curve that is here, and that will be from x squared plus y squared is equals to 4. We believe that um, y squared should be equals to 4 minus x squared. So by the time you take the square root of both sides, then y will be equals to the plus or minus of what? Square root of 4 minus x squared. So here in this case, we have two results for y. We have y equals to positive square root of 4 minus x squared, and we also have the negative part as this. This standard. So that means for this line, for this upper part, that's the positive part all through. We have it as we have the equation as square root of 4. We have y to be equals to square root of 4 minus x squared. And at the same time, for the down part here, the equation of this curve now should be minus square root of 4 minus x squared. So we have two different parts. That is, part A goes to B and B goes to what? And B goes to A. So now how can we simplify this? So let's try to break this down. So I should have, recall from the question given to me, we have integral of y dx, and that should be, in this case, we should have integral along part AB, that's the positive part. So we have it as y dx. And what's our y? Y is square root of 4 minus x squared, then dx, right? Plus, so the other part is part AB, right? And then we also have y. The y value the y expression that we have is negative square root of 4 minus x squared, and also with what? With dx. So this is what we have. So here in this case, what can we do next? So if you have something like this, the only thing we can just do from here is to um, put the limit from part A to B. We only have dx left. So let's check the range for x in this case. From A goes to B. So you see that x starts from 2. right? X start from 2, it ends at where? When x is what? Minus 2. So here in this case, we should have from 2 to minus 2. This is the end point. So that's the change in x expression. So I have square root of 4 minus x squared, then dx. So what of, sorry, this is AB, this is BA. This is BA from B to A. Now for the down part, what is the range for x? That's from minus 2 back to 2, right? From minus 2 back to 2, and I have negative of square root of 4 minus x squared dx. So whatever you have to do here is to just simplify this. And you have 2 to minus 2, and you have minus 2 to 2. So the best way is to just switch this integral by using the property of line integral. That will be the negative of 2 goes to minus 2, just the opposite. So here in this case, we have 2 to minus 2 initially, 4 minus x squared, we have dx. So I want to change this, I want to switch this, and that will be negative of, when I swap it, 2 to minus 2 of, um, I still have a negative sign inside, yeah, 4 minus x squared, then dx. So when you multiply the signs together, you have 2 goes to minus 2 square root of 4 minus x squared dx, then plus integral of 2 goes to minus 2 of square root of 4 minus x squared dx. So I noticed that they have the same definite integral, they have the same lower limit and upper limit. So what is common? I have this and this to be common. So I have the addition of this and this together, that is twice, or just say twice outside, the twice of this thing, since they look alike. So this is the twice of 4 minus x squared, then dx. So whatever you have to do here is to integrate that result. So to integrate this thing here, you also use trig substitution, and from there just break it down to get your final answer. So we can decide to use a calculator by pressing this integral sign as usual, open a bracket, 2 square root of 4 minus alphabet x, then you square it, and then you close the bracket, then you put 2 goes to minus 2, that's the range. So by the time you press equal to, that's going to load. So let me just use the opportunity to solve this. So here in this case, we need to use substitution method, and whatever you have to do here is to let x represent a, let's use any substitution that you wish to use. Let's use let x represent, if I let u to be equals to sine, so now I have an answer, that's minus 12.56. So that's the final answer to that. Minus 12.566, blah, blah, blah. If you have an option, the correct answer is equivalent to minus 4 pi. Because take note of this answer. 5, it started with minus 12, then it ended with 6, 1. So let's confirm. What was minus 4 pi? Minus 4 pi. Is it the same thing? Yes, absolutely yes. So it's still the same thing. But if you want to solve it by hand, no problem. I'll do that. In this case, I want to find the best solution to use. If I use x to be equal to sine theta, I will have sine square theta here. So there is no property for 4 minus sine square theta. So it's not going to work. But what if, this is squaring? What if I have 2 square? That's 4. Then I still have sine square theta. So if I factor out 4, so what happens? I will end up having 4 open bracket 1 minus sine square theta. So that will work. Suppose this is 8. If this was 8 now, so there is no way you can actually work with that, except if you have to apply gamma function to it, possibly. But if it is 4 that we have here, you have 2 squared. If it is 9, let x represent 3 squared. So that's how it works. So here in this case, I have 4. So I'll just use, since 4 is a perfect square, so it really works for perfect squares. So if x is, since I have 4 here, so the square root of 4 is 2. That's the best way to quickly remember that. That's 2. Use 2 sine theta. And if you use 2 sine theta, what happens? You can also use 2 cos theta. 2 cos theta, you want it. So if x equals to 2 sine theta, then what happens? What is dx d theta? So dx d theta should be, differentiate this, that's 2 cos theta, right? Then finally with d theta. So I have my dx on ground. So what about the limits? So for the limit, when x is 2, what we have? When x is 2, this x, if it is 2, I have 2 to be equals to 2 sine theta. So what happens to theta? Theta is equals to 2 cancel 2. I have 1 here. That's arc sine 1. And the sine inverse of 1, that is what? That should be, is this 0? Shift sine 1, that is 90. And 90 is pi over 2. That's pi over 2. So at the same time, I should have, if I try for negative 2, so when x is minus 2, when x is minus 2, I have minus 2 is equals to 2 sine theta. 2 cancel 2, I have 1. So theta is equals to sine inverse of minus 1. So what is sine inverse of minus 1? So see what I have. I have minus 90. That's the equivalent result is minus pi over 2. So now to substitute this thing back, I have, when I have x to be equals to 2, I have pi over 2. And I have minus pi over 2 in this case. So I have 2 roots 4 minus, x is 2 sine theta. So when I square it, I will have 4 sine square theta. And what is dx? Dx is 2 cos theta d theta. Okay? So then the next thing for us to do from here is to um, factor this out. Then if you do this, that should be 0 pi over 2 to minus pi over 2. Then I have 2. I have 4 open a bracket, 1 minus sine square theta. 4 is common here. So I have 2 cos theta d theta. This 2 times 2 is 4 already. This 2 times 2 is 4. I have square root of 4 here, that is 2. So 4 times 2 is 8. So this is the 8 here outside. So whatever I have left now should be just square root of 1 minus sine square theta, and that is square root of cos square theta, and that's cos theta. Now cos theta times this cos theta, that will be cos square theta d theta. So we've done something very similar to this before, right? And I believe that we use um reduction formula, and then that should be in this form. We have 1 over n, and that's 1 over 2. We have cos n minus 1, that's cos 1 theta, then sine theta, then plus. I also have 1 over 2, and that should be theta over 2. Do you agree with this? So this is what you have using reduction formula. So by the time I insert whatever I have for my, when I have minus pi over 2, so that's, when I insert us minus pi over 2, that's minus 90, right? So considering this now, we have 1 over 2 sine, okay, sorry. I want to insert when theta is minus pi over 2. So let me just press this once and for all. I have 1 over 2, then I have cos x. I'm using x this time around. Then I have sine x. Then also I have plus x over 2. So I want to calculate when x is pi over 2. Calculate, see calc button. So use this calc button that you have here. Calculate at when x is minus pi over 2, that's minus 90, right? So that gives us minus 45. So suppose I've actually expressed I can express it in radian. Let's check whether it's going to work. So it's better we work with degree, then it's not working out. So you have minus 45. The first result I have minus 45, right? So this is the first result. Minus, when you insert the lower limit, calculate for 9 or 990, not just minus 90. So whatever I have now is, I have 45. So I have just 45 here. So since we believe that pi represents 180, if pi is 180 degree, then what is pi over 4? That's 45, right? So pi over 4 will give us 45. So let me just substitute that as, I want to express that minus 45 as minus pi over 4. Then minus 45 again, that's minus pi over 4. So I have 8. LCM here is 4, that's minus 2 pi. So 4 here 1, 4 here 2. So 2 times minus 2 pi, that's what? Minus 4 pi. You see, that is very, very simple, which is what we have initially. So anyhow you want is either you use your calculator to test for the options, or you go ahead and solve. So anyone you prefer. Okay, thank you guys. This is how it works. Thank you.